Okay, in this first inequality, again, we want to isolate the x. So I'm going to move the 4 across by subtracting 5x greater than negative 20. Then we want to divide by 5 to isolate the x. I end up with x greater than negative 4. Okay, so this is one of the solution regions that we want to deal with. Now let's do the same kind of thing for the second inequality. I'm going to move the 7 across by adding it. So I've got negative 3x is less than or equal to negative 12. Then I'm going to divide by negative 3, and you guys hear that little bell going off? Ding, 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 right? When you multiply or divide by a negative, flip the direction. So I'm going to have x greater than or equal to 4. Okay, so these are my two solution regions. We want to combine them using either or and. So let's look at the or first. I prefer to combine solution regions using a quick little number line diagram. I just put negative infinity and infinity on the ends, and I'm going to draw two number line diagrams, one for each of the two regions that I found. And then we'll use the number lines to help us combine them. So notice that negative 4 is to the left of 4. So I have to draw a negative 4 here to the left of 4. Otherwise the system won't work. Okay, now to be greater than negative 4, that means I shade in to the right of negative 4. Okay, so everything to the right of negative 4 gets shaded in. That's the solution region for this inequality right here. Okay, notice I don't use negative 4 itself because there's a strict inequality, no equal sign, which means I can't really be equal to negative 4. I could start at like negative 3.99999 and move higher, but I can't do 4 itself, or negative 4 itself. Now, what about the second solution region? Well, that second solution region starts at 4, filled in circle because there's an actual equals on the inequality, and then goes higher, goes to the right. Okay, so those are my two solution regions. Now for or, you have to be in either one. Okay, for an or situation, you can be in one or the other or both. So I would be in one or the other all the way in here. I'll put little check marks, but also here. Because I'm in, at least if I'm in, x greater than negative 4, that's still one of the solution regions. That's still okay, all right? I don't have to be in both with an or, just one or the other. Okay, so the solution for or is actually going to be what we just drew, which is this region here, from minus 4, sorry, I wrote that kind of sloppy, from minus 4 through infinity. Okay, that's the solution for or. Now, how does this change if we do and? Okay, suppose we do and. So I'm going to kind of sneak in here and say, you know what? What if we change this to and? Like this region and this region. That means you have to be in the overlap. You have to be in both at the same time. Where am I in both at the same time? From here all the way to the end. Okay, so for the and, you're going to start at 4 and go to infinity, and that's your answer. That's your solution region. Okay, so for the and, this is our region. So interesting, because they overlap, because one of them is inside the other, when you do the and, you're just going to get the smaller one, meaning the one with the bigger number. It gives you a smaller region because it's a little higher, so we're starting like further up. But still, we want when we have a system like this where one of the solution regions is inside the other, then for and, you need both, so it's going to be the intersection, which means it's going to be the smaller solution region. Okay, just this is your smaller solution region. And then your bigger solution region would be for the or, because if you're in one or the other or both, you're still in the or. Okay, and so that would be starting all the way at negative 4, going to the end. Okay, now at negative 4, we'd have a rounded bracket because we can't really equal negative 4. Okay, and there's always a rounded bracket on infinity because you can't get to infinity. Okay, so this would be for the or solution. And that's because of the way we're set up with one region inside the other. The answer to or is just going to be the larger of the two regions. And the answer for the and is going to be the intersection or overlap of the two regions. Okay, that's it. That's how we do these.